Okay, today we're going to solve proportions, and we're going to use those proportions to solve ratio word problems as well. All right, let's start off by kind of indirectly defining what a proportion is. Which pair of ratios forms a proportion? Um, let's start off with the answer. The answer is B. This is a proportion. Okay, and there's a couple ways that I know I'm correct. One way is because 3/6 times 2 over 2 is 6/12. So 3/6 times 1 equals 6/12. And furthermore, the other ones are not proportions because there's no other way, there's no form of 1, like 2 over 2 is a form of 1, that 3 over 6 can be multiplied by to get 6/9 or to get 6/3. So in other words, we start off with 3/6 on all three of these. 3/6, 3/6, 3/6. There's nothing I can multiply 3/6 by to get 6/9. No form of 1 anyway. There's nothing I can multiply 3/6 by, no form of 1 anyway, to get 6/3. However, I can multiply 3/6 by 2 over 2 to get 6/12. Some other people might say they simplify to the same fraction. And you'd be right. 3/6 is 1/2, 6/12 is 1/2. So that makes them a proportion as well. Let's solve these proportions. Okay. You may have learned other methods in the past, but we've kind of already been doing this anyway, so let's continue to do this. And that is, I'm going to say that C is 12, and the reason I know it's 12 is because 6 times 3 is 18, so 4 times 3 should be C. Okay, and on this next one, I'm going to say that D is 6. And the reason I know it's 6 is because 9 times 2 is 18. So 3 times 2 should be D. Okay, so 4/6 times 3 over 3 would equal 12/18. So C is 12. 9/3 times 2 over 2 would equal 18/6. So D is 6. All right, similar here. Let's solve this proportion. Look at this a little bit differently. E is 3, and the reason I know it's 3 is because 5 times 3 is 15. So 3 times 3 is the only way to get 9. Okay, so I'm going 5 times what is 15? 5 times 3 is 15. So over here, I have to think what number times 3 is 9? 3 times 3 is 9. So 3/9 and 5/15, they both simplify to 1/3, so I know I'm right. Over here, 3 times what is 12? 3 times 4 is 12. So 4 times 4 should be F. It should be 16. Again, it's because 3 times 4 is 12. So 4 times 4 should be F. Okay, and 3/12 simplifies to 1/4, just like 4/16 simplifies to 1/4. So I know I'm right. A wholesaler offers discounts for large purchases. The table shows the price of an item for various quantities. Is the price proportional to the quantity? I mean, right off the bat, when they said that they offer discounts for large purchases, I mean, they're discounting it the more you buy, so I know it's not proportional. So the price is not proportional to the quantity. If it were, then every 10 items you buy would cost 30 bucks. So I'm going to say that 10 times 3 is $30. So 100 times 3 would be $300, but it's not. It's 200. So that right there. And lastly, 1,000 items, if it was proportional, should cost you 3,000, not $1,000. So because when you multiply by 3 every time, you don't get the answer you're getting in the price column. It's not proportional. Retailer sells an item for $5. Brenda needs several of the items. Is the total price proportional to the quantity purchased? In this case, we're going to say the total price is proportional to the quantity purchased, because we don't know anything about a discount for large numbers of quantities, so we just have to assume that this is constantly sold for $5, this item is. So I'm going to say it's proportional as long as the item continues to be sold for $5. Okay, if they start giving you a discount after 1,000 items, then it's not proportional anymore. Solve the problem by creating a ratio table and writing a proportion. The ratio of the length to width of a rectangular room is 5:4. Is the room, if the room is 20 feet long, how wide is the room? Okay, so here's what a ratio table looks like. We'll do length and width. The ratio is 5 for the length and 4 for the width. So some might even label this ratio right here. And some might label this actual. The actual length is 20, so what is the actual width? And then we'll set up a proportion. X must be 16. 5 times 4 is 20. 4 times 4 is 16. So the actual width must be 16 feet. So this is the ratio table where we have a column for the ratio and we have a column for the actual measurement. Same thing here. The teacher-student ratio in the primary grades is 1 to 20. If there are 100 students in the primary grades, how many teachers are there? So my ratio table, I'm going to do teachers and students. The ratio is 1/20, one teacher for every 20 students. There's 100 students, and we're trying to find out how many teachers. So again, this would be my ratio, and this would be my actual measurement of teachers and students. So we can set up a proportion. 1/20 equals x over 100. 20 times 5 is 100, so 1 times 5 would be 5. So there's 5 teachers if there's 100 students. It's the only way to keep it at that ratio, to keep it proportional. Okay, so this is a helpful little tool, especially when we get into some tougher problems where they say, we need to start using a total. We just add another row here for the total between teachers and students. So you'll see that here eventually, but ratio tables. All right, thanks for watching today, and thanks for taking good notes.